This is part 6 of a course on Java, and it covers the instance of operator, which, if you recall, was one we didn't cover when we did operators. That's because it needed rather more technical details than we had covered at the time. So now we're going to cover it. Right, well, the instance of operator, this is what it does. It takes an object reference and a class type. There's the class type there, there's the object reference there, and it returns true if the object referred to is of class T or a subclass of T. Okay, so now the left-hand operator's got to be a reference type. It can't be a primitive type. If it's primitive type, you get a compiler error. And a reference type could be a variable, or it could be an element of an array, if that array is of an array of some particular class rather than an array of primitive type, for instance, or an array of an array or something like that. Now what matters, in fact, is what that reference actually refers to. Okay, not the type of the variable that's being used to refer to it. So for example, if you've got class A and that extends class B, and you say you have this variable defined B of type B, and you set it to be new A, which you can do because A is certainly of type B, then both V instance of A and V instance of B would both be true. So you see, what matters is what it refers to, what V actually refers to, which in this case is A. Okay. Now, if the type on the compile time type of the left-hand variable, this reference over here, if that is such that it can't possibly be of type T, then you'll get a compiler error, and I'll cover the sort of situations when that can arise shortly. And if the reference, by the way, is null, then the answer is false. And if this thing turns out to be true, then what it means in effect is that what you've got on the left-hand side here can be assigned to a variable of type T. Though of course you might have to use a cast to do it. Let's consider the sort of checking that goes on at compile time by the compiler, and let's imagine that we've got this sort of setup here. We've got C1, which extends object, and B1 extends object and implements I0, and interface I3 extends interface I0, and so on. And I've indicated implementation with this dotted line and extends with this solid line here. So that setup there is pretty much what all this down here does. And I've left these details of what these interfaces are unspecified because it's not important to the discussion. Neither are the details of these classes. I've also said let's consider that we've got some variables defined, and I've labelled the variables so that they can be recognized easily when I refer to them later. And I've deliberately not specified what's actually contained in the variable itself. So C2, for instance, that could refer to an object of class C3, for instance, as well as an object of class C2. I've deliberately not specified that because that's a runtime consideration, and we're only looking at compile time at the moment. Right, here's an example of the compile time errors that you can get, and they all give, all these things down here give inconvertible type error. That's what the error message is. And if you look here, we've got C3 instance of B. Now it's pretty clear from here that C3 can never be an instance of anything B, for example, because anything that any variable C3, for instance, would refer to anything down in the tree lower down here, and that can't possibly be of type B. So that's why that gives an error. Similarly, the other way around, B can't be an instance of C3. Similarly, with the arrays, for instance, the same sort of thing applies. A C2 array, an array of type C2, cannot be an instance of an array of type B. Also, if you're looking at arrays, you have to get the number of dimensions of the array correct. So a C2 array is not an array of an array. So that would also give an inconvertible type error. Now, you might wonder why something like B instance of I1, for instance, that doesn't generate a compile time error. And there's a good reason for that, because if you think about it, a variable B, for instance, might refer to anything further down in the tree. And at this particular point in the compilation, the compiler can't be sure what exactly that's referring to. So since any class can implement an interface, a class lower down in the tree than B might be referred to by B and might in fact implement I1. So that's why that doesn't give a compile time error. Obviously, with classes, they can only extend one other class, so that's fairly simple to see compile time errors. But in the case of implementation, that's not so straightforward. Now, there is one exception to that. If class B had been final, it's been indicated as final class B, etc., then that means in effect that B can't be extended. If you mark the class as final, it can't be extended. So therefore, in this case, or in that case, B instance of I1 would in that case give a compiler error. That would again be inconvertible type. Now, interfaces of course can't be marked as being final, so I3 instance of I1, for instance, any variable which would mean that any variable which was of type I3 could in fact also be an instance of I1 or any other interface in effect. And of course that would not give a compile time error. Okay, it might at runtime of course give an error, but that's a different check.